we are going to discuss about
What's up? Guess what? In this video, we're going to talk about selection sort algorithm. Now, as you've seen in the beginning part of the video, learning stuff like this can be boring sometimes. That is why our group came up with some interesting ways of presenting this algorithm for you to enjoy while learning. Hope you have fun and find this one helpful. Let's get started. The selection sort algorithm is a simple yet effective sorting algorithm. A selection-based sorting algorithm is described as an in-place comparison-based algorithm, meaning it doesn't use any other list to contain the sorted elements. Rather, it uses its own list and divides it into two parts, the sorted part on the left side and the unsorted part on the right side. Initially, the sorted section is empty, and the unsorted section contains the entire list. After the sorting process, it will be opposite where the sorted part will contain the entire list while the unsorted part will be empty. When sorting a small list, selection sort can be used. In the selection sort, the cost of swapping is irrelevant and all the elements must be checked. The selection sort algorithm works by taking the smallest element in an unsorted array and bringing it to the front. You'll go through each item from left to right until you find the smallest one. The first item in the array is now sorted, while the rest of the array is unsorted. This process will be done multiple times until all the elements of the list is sorted in an ascending order. The following are some applications of how to use selection sort. Number 1, selection sort consistently outperforms bubble and gnome sorting. Number 2, when memory writing is a costly operation, this can be useful. Number 3, in terms of the number of writes, selection sort is preferable to insertion sort. Number 4, it almost far outnumbers the number of writes made by cycle sort, even though cycle sort is theoretically optimal in terms of the numbers of writes. Lastly, this is important if writes are significantly more expensive than reads, as with EEPROM or the flash memory, where each write reduces the memory lifespan.
Since selection sort algorithm is an in-place sorting algorithm, it does not require additional storage. However, its time complexity is really big. Therefore, it is not very efficient unlike the other algorithms, though it can be useful in some cases. The main advantage of the selection sort is that it performs well on a small list. Furthermore, because it is an in-place sorting algorithm, no additional temporary storage is required beyond what is needed to hold the original list. The primary disadvantage of the selection sort is its poor efficiency when dealing with a huge list of items. Similar to the bubble sort, the selection sort requires n squared number of steps for sorting n elements. Additionally, its performance is easily influenced by the initial ordering of the items before the sorting process. Because of this, the selection sort is only suitable for a list of few elements that are in random order.
The time complexity of the selection sort algorithm is big O of n squared. This is because the algorithm runs on two nested loops. Now, let's discuss the best, average, and worst case scenario for the selection sort algorithm. Best case scenario occurs when there is no need for sorting. Example, the array has already been started, meaning that the array is already arranged in an ascending order. Average case scenario occurs when the array elements are arranged in a jumbled order that is neither ascending nor descending correctly. Worst case scenario occurs when an array of elements must be sorted in reverse order, meaning you need to sort the array elements in ascending order, but they are in descending order. Though, all of the scenarios still runs on big O of n squared time complexity. up?
I'm so confused. I tried understanding our report, but selection sort algorithm is so hard.
Well, you see, selection sort algorithm can be really confusing. But basically, in computer science, selection sort is an in-place comparison sorting algorithm. It has a big and generally performs worse which makes it inefficient on large lists. Selection sort and generally performs worse than similar performance advantage. Selection sort performance advantage over more performance advantage, particularly where
Stop! That's a bit confusing.
maybe some visual representation would help you understand.
Okay, how?
I'm riding in your car. You turn on the radio. You're pulling me close. I just say no. I say I don't like it.
Well, you see, selection sort algorithm arranges an unsorted array into a sorted one where the items would be in an increasing order. Now, what we have here are some of these gens arranged in a non-particular order, and given their height, instead of arranging them like normal people do, we will use the selection sort algorithm. The algorithm starts by assigning the minimum value to the first item on the array list. It now then compares it to the second item on the array list, and if it is greater than the minimum value, then it will ignore it and move on to the next item.
How about if it's less than a value?
If it is less than the minimum value, then it will be the new minimum value, and we will do this process until we finish the first iteration. Now, we will compare John's height and mine's height. Since my height is lesser than John's height, then I will be appointed to be the new minimum value. Now, we will compare my height to Daud's height. Since Daud's height is greater than mine, then we will ignore Daud and proceed to the next item. Now we will compare my height to Polo's height. Since Polo's height is lesser than my height, then he will be the new minimum value, and he will swap with the first item on the list, and he will be part of the sorted list. Now, Fadia, try and do it.
Now, we will set Chris to be the minimum value. We will compare the height of Daud and Chris. Since the height of Chris is less than Daud's height, we will set Chris as the minimum value. Then, we will also compare the height of Chris and John. Since John's height is greater than Chris, then we will ignore John and finish the second iteration. Now, we will set Daud as the minimum value. Since Daud's height is greater than John's, we will set John as the minimum value. Then Daud and John will switch their position.
Now, we have arranged all the items in the array list using selection sort programming. Did you understand that, Fadia? Good. Now that we are done with, I would say, the boring part, we can now proceed to the more interesting part, which is the actual implementation of the selection sort algorithm in Python programming language. The first thing that we need to do is define our example list that we will be sorting using our algorithm. Then, we need to define the selection sort algorithm inside our own Python code. Let's name it selection sort, and let's have it accept an argument, which is our example array. Now, we want to create two nested loops, one that will traverse the list from left to right, and the inner loop which compares the other items and sets the minimum value accordingly depending on the result of the comparison. The first loop will go from index 0 to the index of the length of the list minus 1. Inside this loop, we need to declare a variable that will keep the index of our minimum value, and in the beginning, we set it to I, which is the current position of the outer loop. Then, we define the inner loop which checks to see if there are small numbers after our current minimum value. This time, our inner loop will start at the index of the item next to I, thus I plus 1, and will end at the end of the list, which is the length of our list. Now, we make the comparison inside the inner loop. If the item at the position J of our array is less than the item of our current minimum index, then we need to set the current item to be our new current minimum index. After the inner loop is finished, our current minimum index will have the least element of our list. Then, we are ready to implement the swap between the current minimum index to the first item in the list and form the sorted partition of the list. We implement the swap using this method where we assign the element of our current minimum index to the position of I and assign the element of the position I to the position of current minimum index. This is how we swap the position of the current minimum index to the position of the current I. Now, we can test this algorithm by calling our function and passing our example list. Afterwards, we can just print our list and see the results. Let me copy the results and show it to you. And this is the result that we got from implementing the algorithm. As you can see, we got the result that we wanted and we sorted the list in an ascending order.
Hi again, my friend. I want to congratulate you in finishing this video of ours, and I hope that we made this video a bit easier to consume. And before you go, here are some key points to take note. Selection sort is an effective and efficient sort algorithm based on comparison operations. It arranges an unsorted array into a sorted one, where the items of the list is in an increasing order. You need to select the smallest element in the array and move it to the beginning of the array by swapping with the fourth element. It works great on small lists but does a bad job when handling a big list. It has a time complexity of big O of n2. Selection sort algorithm is an in-place comparison. It runs on two loops and sorts the list using its own and doesn't use other lists.
Once again, thank you so much for your time and I hope you have a great day. Enjoy!